We will do some emergency brakings.
Are you lunch too? Had lunch?
Yes.
Mm.
I guess I just need that one.
Not the right position.
No, that's okay. Just need to activate my function. The colleague forgot to. Okay, nothing will happen there. Okay, so I will demonstrate you our emergency braking system. And the main goal of this system is to completely avoid collisions, and this collision avoidance also at high relative speed. And this is actually also the main difference to current serial systems. They address mainly collision mitigation, and we're going a step further to provide full collision avoidance, and as I said, this collision avoidance also at high speeds. And how does it work? We're using a laser scanner which is mounted at the front of the car, and this laser scanner sees the whole front of the vehicle, and you can see what the laser scanner sees in this screen. And as we get nearer, you will see the object, the orange object will you see in front of you. And the control unit then selects the relevant object, and it calculates the required distance for our braking. And if we go under this distance, the system will brake completely automatically. But before the system braking, the driver will get an acoustic warning, so he can react by his own to the situation. And if he does not react, the braking will start. So I'm going to drive there with a speed of around 70 kilometers per hour. And we will get the acoustic warning, and I'm going to not react, and the system then will brake. Acoustic warning and brake. Okay? So this is actually a full braking as hard as you can get with one cheat. Yeah.
But why this system braking in the last moment? It can maybe more comfortably if you start early braking early.
But it's not a comfort system. It is a system that helps the driver in very bad emergency situations, and it's not a system that should be used by the driver to, for example, to stop his car in front of another car. So it's an emergency system that in best case the driver will never have the braking, only if he's in real danger. But actually in the development there's one big challenge, and this challenge is that the driver can not only brake, he can also overtake the car. And this overtaking is possible after the point where we already have to brake. Now we'll show you this in the next demonstration. This time I'm going to overtake on the left-hand side, same speed than before. And what happens is that we still get the acoustic warning, and if we get closer, we would also have gotten the braking. And this is kind of a dilemma in the development, because on the one hand side, you want to provide the driver with as much protection as possible, but on the other hand, you don't want to annoy him and to disturb his overtaking maneuver. And for this problem, we thought of kind of a new approach that replaces the acoustic beep through a downshift in the automatic gearbox. So we're at the moment of the warning, we're shifting one gear down. And what happens if you shift down? It's just like a longitudinal dynamic movement. Okay? And for the distracted driver, this longitudinal movement serves as a warning. But for the overtaking driver, it serves as a support of his overtaking maneuver. It actually helps him to overtake the car more easily. So I will show you how this works. Same speed than before, but this time we do not get the acoustic beep, we will get the downshift. And we can complete the overtaking very, very smoothly, without being disturbed by acoustic sounds.
But what happens then Driver will turn the steering wheel during the emergency braking.
It will stop.
The braking will stop.
Yes. I can show you quickly. I think we've got the time for that. It doesn't take long.
Yes.
So my colleague will show you another system in this car, so you can actually stay here. But maybe you can switch over to the driver's seat.